Okay, MYP3, this is the if it's all the same to you unit, about linear equations and graphs to start with, and then various other things following that. So just to recap on the notes that we've done in class already. So heading linear equations and their graphs. Linear just means straight line. We can make a table of values for a function like y equals 3x plus 2 and sketch the corresponding graph. So we made a table of values from x, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then some negative values too. So for example, for each of the x's, let's say 4, we put it into this equation to find out y. So when x is 4, y is 3 times 4 plus 2, which is 14. So we did that for all of those, and we found links between the rule, the table, and the graph. Okay, so y equals 3x plus 2. Because you're multiplying x by 3, then every time the y's went up by 1, every time the x's went up by 1, then the y's went up by 3. So that's happening because you're multiplying x by 3 when you're calculating y. And that had an impact on the graph. Every time it went across by 1 on the x-axis, then it went up by 3 on the y-axis. So it affected the steepness or the gradient of the graph. And then the plus 2 on the end, that meant that when x was 0, you just got the plus 2 on the end as the answer. So when x is 0, y equals 2. And that gave you the point on the graph 0, 2. When x is 0, y equals 2. So the fact that it has a plus 2 at the end of the equation tells you that it's going to cut through the graph on the vertical axis, at least, at 2. So those things I've put in little color-coded clouds. The yellow are to do with the coefficient of x, the number in front of x, and the gradient. And then the pinks are to do with the plus 2 on the end, or the plus whatever it might happen to be in an equation that you've got. Okay, so pause the video and just write stuff down if you didn't get it done before. And then here's another one. Y equals minus 2x plus 4. So I had some x values. I made a table of y values calculated from the equation, and then I plotted the points. And then I noticed you had a minus 2 in the equation. It made the values in the graph go down by 2 every time. And then it made the graph itself go downwards from left to right. So for every 1 across, it was going down by 2. So that corresponds to the minus 2. And then meanwhile, the plus 4 was making the value of y 4 when x was 0, which meant that it went through the point 0, 4. In other words, it cuts through the y-axis at 4. Again, jot that down if you didn't get it. So some general notes. Generally, straight line graphs, or linear graphs to give it the proper term, have equations in the form y equals mx plus c. So the m and the c are just numbers. And the m, the number in front of x, the coefficient of x, tells you the gradient, and that's got a Danish term, Helning's tail, or Helning. That's gradient or steepness. And then meanwhile, the plus something on the end, which we call c. Plus c tells you the y-intercept. So that's where it cuts the y-axis or the vertical axis. That's got a name in Danish, skæringspunkt. So once again, pause the video, jot that down if you didn't get it before. Okay, we can use the link between graphs and their equations to enable us to draw the graphs without having to make a table of values every time. E.g., sketch the graph of y equals 4x minus 3. So you could make a table of values like we did before and plot all the points, but hopefully what we've learned so far has told us something about the graph and the 4 and the minus 3 here. Remember, that's a minus 3, not a 3. So the 4 and the minus 3 tell us something about what the graph is going to look like. Okay, so it's telling us that the gradient is going to be 4, because there's a 4 in front of the x. So that means the graph, for every 1 it's going across, it's going to go 4 up. For every 1 across, 4 up. It's going to be quite steep. And then the intercept is minus 3. The minus 3 is telling us that it's going to cut at minus 3 on the vertical axis. So that's what it's going to look like, cutting at minus 3 on the vertical axis. And then for every 1 across, it's going 4 up. 1 across, 4 up. 1 across, 4 up. 1 across, 4 up. So an exercise for you to try. Draw the graphs of the following functions. So pause the video and try and draw the graphs of those. If you're able to do a screen grab and draw the axes, or print out the axes, I guess that's fine, but just as quick to draw some nice neat axes. Do them on 6 separate ones. If you try and do all 6 on the same ones, then that will get messy. Okay, so go ahead and do that before you continue with the video and look at the answers. Okay, so pause the video while you do that. Okay, here come the answers. So first one, y equals 3x plus 5. It's going to cut at 5, and it's going to go 3 up for every 1 across. 1 across, 3 up. 1 across, 3 up, because of the 3x. Okay, make sure it's labeled properly, so you've got numbers on the lines and not in the middle of the squares. X across, y up, and then starting at 0 on each of the x and y axes. So here is the explanation for number 2. It's got 3x, so for every 1 across, it's going to go 3 up. It's got a minus 5, so it's going to cut at minus 5. So start with where it cuts, and then just start drawing a line that for every 1 across goes 3 up, 1 across, 3 up, 1 across, 3 up. Or you might as well say 5 across and then 15 up from where it was. To just make it not only quicker, but easier to get it more accurate by drawing 2 points that are quite far apart rather than lots of points that are close to each other. Here's the next one. So y equals minus 3x plus 5. So the plus 5 is telling us the intercept. That's 5. And then the minus 3x is telling you that for every 1 across, it's going to go down by 3. So 1 across, 3 down, 1 across, 3 down, like that. Number 4, y equals minus 3x minus 5. Okay, so I should have really extended my graph axes here, but it's cutting at minus 5. 1, 2, 3, 4, minus 5. And then it's got a gradient of minus 3. So again, for every 1 across, it's going 3 down. 1 across, 3 down, 1 across, 3 down. Number 5. Okay, y equals 0.5x plus 4. So again, it's cutting at 4 because of the plus 4 on the end. And then for every 1 across, it's only going up by a half. 1 across, 0.5 up. 1 across, 0.5 up. 1 across, 0.5 up. Or just to get that accurately and quickly, you might as well say something like 10 across, 5 up. Okay, the final one. For some reason I haven't done it on the graph, but the minus 1 here is telling you that it's going to cut at -1. I think the reason I didn't do it on the graph is because normally in class I get somebody to come up and do it. And the minus 0.25 is telling us that for every 1 across, it's going to go down by 0.25 of a square. 1 across 0.25, 1 across minus 0.25. Or we might as well say for every 4 across, it's going to go down by 1. Okay, so it's going to cut here at -1, and then for every 4 across, it's going to go down by 1. It's going to go -1. It's a fairly shallow graph, downwards from left to right, cutting at -1. That's what you should have got.